All right, we're going to go through a few conceptual questions that are involving, in some way, motion in an electric field. So some sort of charge or combination of charge, and looking at some aspect of motion. So as usual, answer the question on your own first and check your answer. So here is our first question. The correct answer here is Z. Just conceptually, if we think about what's creating this electric field, it's not the electron, because an electron cannot exert an electric force on itself. So this electric field is created by something that's positive up this way and something that's negative down this way. I know this because electric field lines always point away from positive charges and point towards negative charges. Well, an electron, of course, is going to be attracted to positive charges. And so Z is the correct answer. If this had been a proton, it would have followed path Y. If it had been a neutron, it would have followed path W, because neutrons are neutral, not charged. Here is another, well, if my screen will scroll anyway. There we go. Here is another question. So the correct answer here is A. They're both protons, so they both have the same charge. But remember, the force they experience depends upon the strength of the electric field they are in. And yeah, that would equal MA. So A is in a region that has a larger electric field than B. And that is because those lines, those electric field lines, are closer together. So in a picture, pictorially, closer lines represents a stronger field. So A is in the stronger field, which in turn means a bigger acceleration. All right. Here's another question. Correct answer here is C. So we know the acceleration depends upon the force. The force depends upon the field. That didn't work out well. So Q times E is MA. They're both protons, so they have the same Q, the same mass. So the only way they would have a different acceleration is if they were in a different electric field. Okay, infinite plane. If you go and look E of a plane, eta over epsilon naught. Epsilon naught's a constant. Eta is the surface charge density. So since they are essentially right next to the same plane, or very close to the same plane, this is the same value. this electric field is constant. Sorry, my computer is having a serious lag issue. So what I'm writing is not showing up very quickly. So since the electric field near an infinite plane is constant, these protons are in the same electric field, thus they have the same acceleration. Here's another question. Correct answer here is E. None of them experience a net force. And that's because the electric field is uniform. Dipoles are made of equal charges, equal magnitude, I should say, one positive, one negative. So the force that the positive one is feeling is equal and opposite to the force that the negative side is feeling. So the net force on all of these is 0. They're going to potentially turn because of a net torque. All right, one last question. So the correct answer is C. C is not going to rotate because it is already lined up with the field. Now it is lined up opposite the field. This is considered an unstable equilibrium. What that means is if anything were to knock this to the side, even just barely either side, it would twist all the way around, because the lowest energy value, the ideal alignment is to have the dipole moment lined up with E. But because they're perfectly aligned right here, C is not going to rotate, so it has no net torque. B is going to rotate. The negative is going to come that way, positive that way. So B would rotate clockwise, and actually so would A, to get lined up with the field. And because of the attractions to the positive and negative charges creating the field.